Probability is why we're going to look at probability distribution. We will look at what is called the random variables. Under random variables, we have the following formulas. We have what is called our expected value, which is given by EX. This is actually the mean. It's given by summation of X and the probability of X. We also have what is called the variance, which is given by this formula here. The summation of X squared PX minus the mean. Then we have what we call the standard deviation, which is simply the square root of variance. So we're going to look at one example where we're given a function of X with the probabilities for the values of X, that is 1, 2, 3, 4, and 5. And we're given the probabilities 0.1, 0.3, 0.15, 0.25, 0.2. The sum probability must always add up to 1. So we're going to find each of them as follows. We're going to find the probabilities. We're going to arrange them as follows. We have our values of X. And the probability respectively. So here we have 1, 2, 3, 4, and 5. Here we have 0.1, 0.3, 0.15, and we have 0.25, and we have 0.2. When we add this, we get 1.0. And here we're going to square this. We have 1, 4, 9, 16, and what? 25. So we multiply X times PX. What do we get? This by that, we have 0.1. This by that, we have 0.6. Here we have 3 times 0.15. What do we get? 0.45. 4 times 0.25. What do we get? 1.0. 2 times 0.2. We get 1.0. So when we add all this, what we get is the expected value. This is summation of X times PX. What are we getting as our sum total here? So this is 1, 2, 3, 3.15. So this is our expected value. Okay, then we go to X squared px. We're multiplying this by the probability. So here we're going to get 0.1, and this by that we're going to get 1.2. 9 by this, we're going to get 5.4. So we're going to get 1.35. Apply this by that, we're going to get 4. Apply this one by this, we're going to get but we get 0.2, we're going to get 5. So when we add up all this, what do we get? This is 5. This is 6. This is 11.
We get 11.65.
11.65. So to find the variance, using the formula to find the mean, which you can write as the letter E and X. Sometimes I leave it like that. This is the expected value. But if you want, you can put it as summation of X times PX. So in this case, okay, if you don't use a table, you're simply multiplying 0.1 times 1 plus 2 times 0.3, 3 times 0.15, and 4 times 0.25, 5 0.2. So this, when we add it, we found our 3.15. That is our mean. Find our variance. We have 11.65 minus 3.15 squared. That is the formula for our variance. This answer minus the square of that. What are we getting? What are we getting?
We're getting 1.7275.
1.7275. Okay, then what becomes our standard deviation? What becomes our standard deviation? That is what you found. You found 7 point? 1 point?
Sorry, just a minute. 11.6 minus 3. 1.7275.
Okay, 1.72. 1.725.
Yes, 7275.
Then our standard deviation would therefore be the square root of this.
Square root, which is 1.3143.
1.3143.
Yes.
Then you're asked to find the probability greater than 3. Which probabilities are we looking at? Greater than 3, we are looking at the probability of what? 4 and 5. What is the probability of
4 and 5.
0. We check on 4, the probability of 4 is 0.25. And what's the probability of 5?
0.2.
So the probability greater than 3 ultimately becomes 0.1? 0.45. Is that clear?
Yes.
And I can go to your exam questions here. We are told that the table here shows the probabilities of cells. So here cells is 10.5 and under 20, 20.0 and under 20.5, 20.5 and under 30, 30.5 and under 30.5, and 30.5 and under 40. Find the expected cells in a month. Find the variance, find the standard deviation, and find the probability that cells will be above 30,000. Let's start with the last one here. What's the probability that the cells will be above 30,000? What are we looking for?
Probability above 30,000, isn't it 0.2 and
0.2
and 0.12?
Yes. So 0.22 and 0.12. All right. That is the sum. Then these are in thousands. This is like 10,000, 500, and 20,000. So you need to calculate the value of what? Of x by finding the midpoint. Okay. So value of x here would be what? 10.5 plus 20.0 divided by 2. What do you get?
10.5 plus 20 divided by 2 is 30.5.
Divided by 2?
10.5.
15.25.
15.25. Then the next one? And the next one? 25. Next one?
20.25.
Next one? 5.25. Okay. So it keeps increasing by what? By 5, 5, 5. So how do we find the mean from what we've talked about? Multiply x times px. And the total is our mean. So multiply this times that, what are we getting? In short, to avoid wastage of time, from what I've done here, able to answer this question to find out the mean and the variance and standard deviation. Is that clear? What you needed is to find the midpoint. All right. Because if I give you time to start calculating, some of you don't even have a calculator right now. Then when we go to the probability, we're dealing with binomial distribution. binomial means by. So the formula for binomial is x is given by n combination x. The p to the power x, and the q we have n minus x. So there are a few hints you need to know whenever you want to know that this is a binomial. You're always given the sample size. For instance, you're given sample size of 5, and you're also given our p. For instance, you're given a p of 20%. Q is a brain mark. You calculate is simply the difference from 100. So if p is 20%, q should be 80%. In decimal, this is what? 0.8, 0.2. So you're asked, but A, find the mean of this distribution. The mean is simply given by n times p. Where n is 5, where p is 0.2. So our mean for this binomial is 1.0. But B, you could be asked to find the variance. The variance is NPQ. So this is 5 times 0.2 times 0.8. So this is going to be 0.8. And the standard deviation is simply the square root of the variance. So square root of 0.8, and you can get the answer. Another question they'll ask you is, why is this a binomial distribution? In short, they're asking you to find out the characteristics of what? Binomial. There are three characteristics of binomial. Number one, is that each event has an equal chance of occurrence. There are two possible outcomes. That's called binomial. There are two outcomes. Number three, they occur independently. There's what we call independent occurrence. So this is your part what? D. Part E, they ask you to find the probability of x 0, 1, 2, and 3. Then I'll ask you to find at most what? 2. And they also ask you at least 2. Each of these ones here, we need to use a formula. At most 0, 1, 2, 3, you need to use this formula here. So we have our n as 5 and our p as 0.2. And our q obviously is 0.8. So we need to find each of these ones here starting from 0. X is equal to 0. We have 5 combination 0. Since our 0 is our x. And here we have p, which comes here at 0.2, and the q, which comes here at 0.8. 0 will come here on top of the 0.2, and the difference 5 minus 0, you get a 5. So 0 combination, 5 combination 0 is 1. 0.2 to the power 0 is 1. Then 0.8 to the power 5. What are you getting?
It's 0.32.
0.32. 32 what?
7. 7.
Okay. So this
6, 8.
0.32, 7. Then if you find the probability x is equal to 1, 5, 1, so this is 0.1, 2, 0.8. So this comes here, and the difference here is 4. Always make sure that the numerators, the powers will add up to what is on top here. So 5 combination 1 is 5. 0.2 to the power 1, 0.2. 0.8 to the power 4. What are you getting?
0.4096. 4096.
The final answer is what? The same 0.4096. Because this to give you 1. Okay. Then when I go to the probability x is equal to what? 2. Over here we're going to have 5 combination 2. So here 0.2 to the power 2 and 0.8 to the power the difference 5 combination 2. The difference can be 5 minus 2, we have a 3. So 5 combination 2 is what? Is it 10?
Yes.
Then 0.2 to the power 2 is 0.04. Then 0.8 to the power is 0. What?
512.
Pardon?
512.
The final answer becomes what? 0.
0.048.
0.048. Okay.
No.
So now help me find
0.208. 2048.
2048.
Yes.
Correct.
Okay, then x is equal to 3. Try to find that one. 5 combination 3. 0.2 power 3. 0.8 the power 2.
Power 3.
Pardon?
Zero 0.2 to the power 3. There's something wrong there.
Yes, there's something wrong. It has to be 0.4. 0. And 8 should be 0.2.
Yeah. 0.8 to the power 2.
Yes.
Point what?
Yeah, to the
Power
power
2,
2.
yes.
The answer is 0.0512.
Okay. 0.0.
0.0512.
Okay. So this is how we find the probability of x is equal to 4 to 3. Then now we want to know what does it mean at most 3. Probability at most what? At most 3. Most 2, sorry. This means probability of 0 plus probability of 1.
The one we're solving was at most 3.
At most, no, it was exactly 3. That one was finding individuals from 0, 1, 2, and 3 individually. Now this one is at most 2. So you need to find the probabilities of each of these ones here. You add them. At most 2 means 2 and below. At least 2 means 2 and above. So find the probability of at most 2. So we're finding the probability of what? At most 3. So it means we are adding the probability of 0, 1, 2. At most 2. So what was the probability of 2? 0.327. What's the probability of 1? 0.4096. And what was the probability of 2?
0.2048.
0.2048. What are you getting when you add all these?
0.9414. 9414.
Okay. So now, if we're asked to find at least 2, what are we doing?
It should be 2, 3.
Up to the last number 5, right? 2, 3, 4, and the probability of 5.
5.
Now, since this is a long cut, you just subtract 1 minus the probabilities that are not identified. What probabilities are not there? 0 and 1. Because we know the total probability must add up to 1. So add probability of 1 and 0, then subtract the total from the total from 1. So what are you getting?
0.2634.
0.2634.
34.
That is how we find probability. Now you need to understand the concept here. Suppose we are asked to find the probability of at most 4. What does at most 4 mean?
At most should be 0 to 4.
0 to 4, but the shortcut is what? If there are 5 of them, the shortcut is 1 minus the probability.
Yes, 1 minus 0.
Probability of 5.
Yes, probability 5.
Yes, you need to understand the easy way out. All right?
Yes.
Okay. So So now we go to the tree diagrams, probability tree diagrams. Now, you need to understand that binomial goes hand in hand with probability trees. So you'll be taught, firstly, you need to know the concepts. These concepts are called the axioms. We need to know that probability must always be equal to 1. So the probability between A and B must be between 0 and 1, can't be more than that. Then probability, when you add A and B, it is simply the probability of A plus probability of B minus the intersection A and B.
Yes.
Then we have what we call conditional probability, which is A given B. This one must be equal to what? Make sure the bottom guy goes down here.
Probability B.
B will go down. Then on top, we're going to have what? A and B.
A and B.
Okay. So you told me, suppose you had the other way around. B given A. How do we expand this? A will go down, right?
Yes.
Then on top, we're going to have what? B intersection A.
B intersection A.
Exactly. You must also know, therefore, that if you cross multiply the intersection of A and B, will be simply you multiply B, A given B, times the base itself, times the B. All right? Or
Yes.
A intersection B again here, because A intersection B is same as B intersection A. Cross multiply here will be B given A. Multiply what? Multiply
Probability.
A. And finally, the probability of an individual element A is simply given by the number that A has over the total events. So I'll quickly go through 3 key theories. Number 1, the basic one of the table. If you have A, B, X, and Y, you have 2, 4, 6, and 8. First thing is you total up. B is what? 8.
7, 8,
Here we have what? 12.
12,
Here we have what? 6
6,
and 14. The total here of what? 20.
20.
So what's the probability of A? I said the total that A has,
Probability
total of A,
is 6.
and the grand total of the events. The total events E is what? 20.
6 over 20.
Is over 20. Okay, then B becomes what? Eight over 20. Then X becomes what? The total for X is what? 14 over what? 20. Okay, Y? What becomes Y? The total for Y?
12 over 10.
12 over 20. Then what is A intersection B? I said for intersection, you convert this intersection to a slash. So the shortcut is where they meet A and B. Where do they meet? At 2. You draw a plus. A and B meets at 2. but over the grand total, which is what? 20. So tell me, what is x intersection y? X intersection y. When you draw a plus,
8
what do they
over
mean?
20.
8 over what? 8 over 20. All right.
Yes.
Sorry, excuse me.
Mhm.
The screen kind of froze, so I didn't see how you did the NA over NE. What is NA over NE?
The number of A elements. So n
Oh.
for A there are 6. Then the number of all the events, this is 20. To find the probability of any individual. For instance, you're in a class, you have 3 ladies and 7 gents. The probability of picking a lady is 3 out of the total, which is 10. That's what we're doing here. Probability of picking an A is 6 out of the total. We have 20 elements. B is 8 out of the total, 20. X is 14 out of total. Y is 20 out of total. But A and B intersection B means what is common. Where do they meet? What is common is what? 2. 2 over what? 20. How about X and Y? Where do they meet? 8
8.
out of 20. But if we're given A given B, where do they meet? They still meet at 2. But the total for the base here, total for B. So B, the total is what? 8. Then if we do B given A, you still meet at 2. But this time the total for the base has changed. Total for A is what? 6. Let's try what is X given Y? You tell me, and Y given X. Quickly.
Eight x given y, it's 8 over 12.
Over 12. Then Y given X.
Y given x is 8 over 14.
Excellent. Therefore, what is A intersection B? Probability of A plus probability of B
Probability B
minus the intersection.
minus intersection.
A union B, so minus intersection. So what is our A?
Our A is 2
2
over 8,
2 over what?
2 over 20.
Over 20. Our B?
No.
B?
No,
Or 8.
no. Our A is 6 over 20,
6 over 20. And
and
our
our
B?
B is 8 over 20.
8 over 20 in the intersection.
The intersection is 2 over 20.
Okay.
How is X over Y 8 over 12?
Where they meet X and Y, they meet at 8.
They
And the
meet at
total
8,
for the
yes.
bottom number. The total for X is what? 14.
Oh,
Similarly, Y over X, they meet at 8, but now the total for Y was 12.
okay.
Is that clear?
Thank you. Yes, it's clear.
Right. So now, please share the links to your colleagues so that the evening as I meet, I'll be fortifying on this. I don't want people to be behind. Then you find the final answer as 12 over 20.
12 over 20.
All right. So the word and means what? Intersection
Intersection
or times.
or multiplication.
The word or means what? Union.
Union or
addition.
plus.
If we go to an exam type of a question here, we're given the following courses. We have AFIN, ECA, ECF and what?
BB8 240.
So what you need to do, you find the totals. So you find the totals. Find the totals. So the first thing you need to do is firstly find the total. So affine, the total is 180. ECA, the total is 70. Then ECF, 150. BBA, 240, 100. Then you total up from either directions. Then to find the probability of what? ECF.
CF
So it's 150 over what?
250.
250.
Okay. 150 over 250. What did you get as a decimal?
0.6.
0.6. Then affine.
So 180 over 250.
80 over 250. What are you getting?
0.70.
72.
0.72. Then 240 and pursues ECA program.
240 and purchase ECF program. 240.
And means what?
Intersection.
Intersection.
So it's 20 over 250.
20 over 250. You agree with him?
Yes.
What's the answer?
0.08.
Wait, were you people copying from each other?
No.
Okay. Then affine gives us that he studies ECF.
100 over 150.
Pardon?
100 over 150.
100 over 150. What do you get?
0.67.
0.7?
0.667.
0.67. All right. Are you agreeing with him?
Yes.
Okay. Yes, then next, here what do you get? Studies BBA 240O pursues an affine program. O means what?
It's
Union.
union.
Union. Who got the final
Formula
answer?
is, oh, okay. I'm trying to solve it.
What was the final answer?
That's the minutes.
That's the minute. 0.8.
200 over 250.
Which was
Hmm?
200 over 250. The final answer is what?
Yes.
0 point.
Correct. 0.8.
0.8.
Wow. This is what you're supposed to do. So the other remaining part is now where you apply the axioms themselves. The probability, so for instance, a given of A is 0.2, probability of B is 0.3, and probability of A given B is 0.4. So how do we find the probability of A intersection B? So we know that whenever I given a conditional probability, just expand it first.
Expand it.
So B
So
will
it
go
will
down
be
here. On top, we're going to have what? A intersection B,
A intersection B.
correct? Then we substitute what we have. A given B, 0.4.
0.4.
The intersection, what we're looking for.
That we're looking for
Then probability of B,
is 0.3.
we cross multiply this by that, A intersection B. Then you multiply this by that, 0.12. Then you're asked to find the union set. A union B. Who remembers the formula? It is A
Equals to probability A plus probability B minus B intersection B.
What was our A?
0.2,
Our B?
0.3,
Our intersection?
and 0.12.
What do we get as a final answer? What is the complement of A and the complement of B?
The complement of A, it will be 1 minus 0.2.
So 1 minus A itself is the opposite of this one. So they should add up to 1. So what are you getting? 0.8.
0.8.
What is the complement of B? 1 minus B
So
itself.
1 minus 0.7.
Okay. Then how do you find B given A? A goes down.
Yes.
Then on top we have what? A intersection B. We usually start with the alphabet, which comes first in the alphabet. So do we have A intersection B? Yes, we found it at 0.12. And what is our A?
0.2.
0.2. So what do you get?
0.06.
0.06. All right. Now, are A and B mutually exclusive?
That's 0.6, eh?
0.6, eh?
Yeah.
Thank you. 0.60. How do we know A and B are mutually exclusive? If the intersection is equal to 0. So A and B are mutually exclusive if their intersection is equal to 0. Otherwise, we say they're not mutually exclusive. So A intersection B was 0.12, which is not equal to 0. So we say they are what? Not mutually exclusive. The next one, how do we know that they're independent? A given B must not be affected by what is down there. It must still be A. A given R must still be A. So that's what it means. If B given A is to be independent, you maintain what is on top, which should still be B. So A given B must go to A. So you compare, what is our A given B? 0.4. And what is our B? Probability of A? 0.2.
0.2.
Are they the same?
No.
No.
So you can confidently conclude that they're not what? They're not independent. So I'll need you to do this at your own time. A given probability of A, probability of B, A given B. You can capture this and you try this. I'll need it in the evening as we meet. Have you captured it?
Yes.
Yeah. Yeah.
Right. So we end here for now.